Hello all. So this session is basically for those who want to switch their career into solution architect role, or if they want to become a AWS solution architect, right? We are going to discuss about an architecture diagram that has been created for crew management system of an airlines, right? So basically what we are going to discuss here is about an application that has been developed for British Airways, and this is going to schedule the trips for the crew members. Crew members will include pilots and flight attendants, and they will be getting their trip details through their mobile application. On the other side, we will have corporate system or the admin or any other corporate staff who is going to schedule their flights, right? So let's say we have flights of British Airways that goes from London to New York, London to Sydney, and New York to London, right? So in their system, these corporate people are going to schedule the flights of these crew members, and these members will be updated about their next flight in their mobile app, right? So let us go and understand how the architecture looks like. So this is the architecture diagram of this application, which will be running on AWS, right? On the left side, you see we have crew members who is trying to access the application, and on the right side, we have corporate users who will be scheduling the flights for these crew members, right? The bigger box that you see is basically the AWS is basically representing the AWS cloud, right? And then we have other boxes that represents how each services of AWS are connected and how they are helping to run the application, right? We have set up monitoring and logging. We have also set up the security things so that there is no data breach, and we have taken care of high availability of this application by deploying into multiple regions, right? And we have used uh, EKS cluster for running the microservices, right? For simplicity, we have taken only two services. One is trip retrieve services, which will get the details and which will make these details available to the crew members. And the other EKS cluster will be running the trip update service, where the corporate user will be updating the trip details for these crew members, right? So here you see when the user tries to log in or any of the crew members try to log in, he is first hitting the Amazon Route 53, okay, which is actually the use browser or maybe their mobile app, and they will be entering this application URL if they are using browser, or they can simply use the mobile app which will directly connect to the URL. Amazon Route 53 will resolve the address, or you can say, since it is a domain name resolver, so it will map the domain of this application with the server where it is running, right? And then it is going to show them the front end, which is protected by Amazon Cloud Front, which is a content delivery network. And the front end data, or you can say the UI part, has been stored in Amazon S3 bucket, right? So once these members access the application, they will be getting the UI, and from there they will be accessing the service, right? These services are running in two regions for high availability, right? And each and every event that is happening here will be logged using CloudWatch, and we are going to check the services of each of this service using a AWS public health dashboard, and every cloud event will be monitored and recorded by AWS CloudTrail. For security purpose, we are going to encrypt data using AWS Key Management Service. We will need AWS Certificate Manager, secret manager for storing the secrets. We will be using Amazon Cognito for maintaining the user pool, and we will also need AWS identity and access management so that we can create different IAM roles which are required by these services, right? So let us go further and understand what are the important services that has been used here and what is their purpose. Okay. So for crew members who are accessing this application through through their mobile apps, the very first service that they are going to hit in this architecture is Amazon Route 53. It acts as the DNS service. It resolves domain names. Example, let's say the application name is app.crewmanagement.com, and it intelligently routes requests to the nearest AWS region based on user location, reducing latency and improving availability. Means, let's say this region is in US and this region is in Britain, right? So if the crew member is in US, for him the nearest location where he will be using the application is New York, so he will be accessing the infrastructure, or you can say the servers which has been deployed in New York region, right? On the other hand, those who have reached London or in some other location, they will be accessing the application to the nearest region. If they are in Sydney, then for them maybe London is the nearest location, or if they have already reached London, in that case they will be using this server. Whenever they will try to access the application, they will be accessing this region. Okay. So next service that is being used is Amazon Cloud Front, which is a content delivery network that caches and distributes content globally. It serves static assets, example, let's say, and JavaScript files. So from edge locations closer to the user, speeding up load times so that they can immediately open the application, they can access the data without any delay. And these assets are stored in an Amazon S3 bucket, which provides durable, scalable object storage. Okay. The next service that is being used here is regional Amazon API gateway, right? If you get back to the architectural diagram, you will see that in both of the regions, we have Amazon API gateway uh, service integrated here. Okay, so once they hit the application, once they log in into the application, whatever the requests they are trying to get about their schedule, they will be sending the request, and that request will hit this Amazon API gateway, which will convert it into any of the API methods like get, post, delete, update, whatever you have learned about API gateway. And that API gateway will be going inside a VPC, which is running this cluster. Okay, and which is actually which will first hit the network load balancer, and then the traffic will be distributed to the cluster. Okay, the first cluster that you see is trip retrieve services, means the data that has been uploaded, the schedule that has been uploaded, or you can say the flight that had been scheduled, which will be can be that data for that can be retrieved from this cluster. They are going to access trip retrieve services, which is running in this cluster. Okay, and the data is actually present in Amazon Aurora database. Okay, and we have write forwarding enabled here. In both the region, we have the Amazon Aurora database installed, and the data will be synced in both of the regions, and they are going to access the data. Okay, so regional Amazon API gateway, it will handle dynamic API requests for reading crew trip data. It acts as a secure entry point to the backend application tier, managing authentication, throttling, and integration with downstream services. Requests are routed through CloudFront for optimization. This setup ensures crew members get fast, reliable access even in remote locations with failover to other regions if needed. Means if any of these server fails in one of the region, they will be able to access the application in another region. Let's say the New York, there is some issue in the New York servers and application is not running properly there. In that case, they will be able to access the application or the services that they are looking for in this region, which may be London. Okay. Then we have database layer, which has been established for high availability and low latency. The core data storage uses a globally distributed database to support reads and writes with minimal downtime. So Amazon Aurora Global Database is actually a managed relational database, which can be PostgreSQL, MySQL, compatible, and it will be spanning multiple AWS region. It includes a primary writer instance in one region and replicas reader instance in another region. Okay, means this database that you see, if data is being updated here, it will be synced to the other database that is running in other region, right? Which is actually the replica of this database, and we will have read only replica database in other region. Means if the flight schedule is updated in New York region, people in London region will be able to read the new schedule, but they'll not be able to modify it. Okay, it will be read only replica database. Okay, so this is for high availability. If replicas provide failover, if the primary fails, a replica can be promoted automatically. Low latency reads are served from the nearest replica, ideal for global crew access. Write forwarding, a key feature allowing applications to send write operation, example trip updates, to any replica, which then forwards them to the primary. This enables write anywhere without compromising consistency. Data includes crew trip details, schedules, and updates, ensuring sub-second query times, right? So this design support disaster recovery across multiple regions, which can be US East and EU West, while keeping data synchronized. The third thing that we see here is application deployment in multiple regions. So the backend services like crew trip update and retrieve are containerized and deployed for global reach. And we have done multi-region deployment. The application runs in multiple AWS regions to minimize latency and provide redundancy. If one region experiences issue, traffic shifts to another region. Means if anything happens in this region, this traffic that is coming from the user will be shifted to the other region. Okay, if let's say if any damage happens to the server which are running in New York, then the application traffic will be diverted to the infrastructure which has been set up in London region. Okay, so in that case it will be still application will be still available, and there will be no issue for the crew members, or let's say the corporate members, to work with the application. Cloud, AWS cloud formation, this is used for creating the complete infrastructure stack where either EKS clusters, networking, etc. can be created. We can also use Terraform, that is not an issue. But yes, we can, since AWS CloudFormation is native to AWS, so we can go for AWS CloudFormation as well. We have deployed Amazon Elastic Kubernetes Services, which is a managed Kubernetes platform for running containerized microservices. The trip update and retrieve services are actually the microservices which are deployed as pods in EKS cluster. Network load balancer, it will route the incoming traffic to the EKS cluster. It operates at the network layer for high performance and low latency. Then hands off to Kubernetes services for application specific routing, example to the update or retrieve endpoints. This container based application approach allows easy scaling. Okay. Then on the right side, we have corporate user and system integration. Corporate users, or you can say the schedulers and internal systems, they connect securely for updating and retrieving, reading data. And they're not connecting through any other services. They are connecting through AWS Direct Connect, right? So if you have gone through AWS services, you might have heard about AWS Direct Connect. It provides a dedicated private network connection from on-premises corporate networks to AWS, bypassing the public internet for lower latency, higher bandwidth, and better security, right? Which means if your application is running on AWS and your scheduling system is in your own on-prem data center, okay, so you will be able to connect to your AWS infrastructure using AWS Direct Connect, okay, which is highly secured and which will not go take your traffic through internet. It will not use the internet. It will directly connect with your AWS infrastructure, right? Private Amazon API gateway, a fully managed API endpoint accessible only via private networks, example VPC. It exposes services for the crew scheduler to perform updates, writes, and reads on trip data, integrating with the EKS backend. This contrasts with the public-facing regional API gateway in step one, ensuring separation of external and internal traffic. Okay. For example, a corporate scheduler could update a flight crew assignment, which propagates to the global database and becomes available to the crew apps, right? So here you will see there is difference between the API gateway implementation for corporate user and for the crew members. In this case, the API gateway that has been implemented here is regional and here it is private. Okay. So yeah. Yeah, so private Amazon API gateway, they are fully managed API endpoint accessible only via private networks, right? Means this will be accessible only through AWS Direct Connect. It will be within a VPC, within a private VPC network, okay, which has been created, or you can say a private network tunnel which has been created using AWS Direct Connect. Okay. On the other hand, the crew members, they will be hitting the regional API gateway, which is exposed to the internet. Okay. A corporate scheduler will be updating the flight detail and the crew member will be able to access it without any problem. For monitoring and operational health, we have used Amazon CloudWatch, which will collect metrics, logs, and events from all services. Example, API gateway latency, EKS pod health, Aurora query performance. Right, it enables alarms, dashboards, and automated responses. Example, scaling EKS based on CPU uses. Additional monitoring tools like AWS X-Ray for tracing request end-to-end or third-party integration for deeper insight can also be used. And this provides centralized management, helping operators optimize cost by identifying underutilized resources and detect issues proactively. Okay. The security feature that has been implemented is embedded throughout for compliance and protection. AWS Cloud Security Services, files that you have stored in S3 and the database and the data in your database, they will be using AWS KMS keys for encryption, and TLS will be used for data that is being transmitted from one location to another using API gateway and CloudFront. Okay, end-to-end encryption is there. Data is encrypted from user devices to storage using services like AWS Key Management Service, and credential protection is done using AWS Secret Manager. Okay, so all the database secrets, API keys, they will be stored in AWS Secrets Manager, and it will be rotated automatically and never exposed in code. Other implementation that needs to be done is identity and access management rules for least privilege access, VPC security groups for network isolation, and compliance with standards like SOC 2 or PCI DSS, right? This ensures sensitive crew data, example personal info, flight details, is protected against data breaches, right? So basically the flow looks like this. User flow is uh, from your mobile app, they will be routed to Route 53. They will be hitting Route 53, which will take them to cloud front, and they will load the static data which has been stored in S3 bucket. API calls will happen, which will take them to the network load balancer and finally to the EKS cluster where your retrieve microservices is running, and the data will be retrieved from Aurora database, which will be read only replica. Okay, for corporate people from on premises, they will be accessing the AWS infrastructure using direct connect, which will be hitting a private API gateway, which in turn will hit network load balancer, and they will be updating the services which is running in Elastic Kubernetes services, and they will be writing in Aurora using write forwarding. Okay, the benefit of this infrastructure is it is highly available, high availability, means it has been set up in multiple regions with automatic failover. Services like EKS and Aurora scale dynamically, and cost effectiveness, pay for use model, cloud front S3 reduce data transfer cost, flexibility, easy to extend for other services, example adding analytics with AWS Lambda, and security, comprehensive encryption and monitoring has been done. Okay, understand to read the architecture, and you should be able to find out what each and every services does, right? You should have very deep knowledge of every AWS services that you are going to use in your architectural diagram. If you want to become a solution architect, then in that case all the services that are present in AWS should be very well known to you, right? Half knowledge will not work. You will have to implement those services, understand each and every feature of those services, and then only you'll be able to create the architecture diagram for any application solution. Okay, so we will come up with more architectural diagram. We will understand what each services are doing here. We will also implement these infrastructure using Terraform or maybe using cloud formation template. Okay, so thank you all. We will come up with some another architectural diagram soon.